Hello everyone, I welcome you all to today's session wherein we are going to discuss the XAT 2025 QA and DI section together. In this particular part, we are going to take up the QA, right, which will be followed by the DI as well. Let's get started. So, we'll be taking up the questions one after the other. Okay, what you may do is, if you wish to come along, whenever you see a question, you can just pause it on your screen, try it out on your own, mark the answer, keep it ready, and just verify what your answer is with the answer that we get here. Let's get started. Question number 1 says the market value of beams made of rare metal has a unique property. The market value of any such beam is proportional to the square of its length. So I'll just write it here. So value of the beam, market value of the beam is directly proportional to, proportional would mean directly proportional to square of the length. So whatever the length is, it's square. Due to an accident, one such beam got broken into two pieces having lengths in the ratio 4:9. So there was one long beam which was broken into two parts, one part of length 4K suppose, the second part of length 9K, suppose the ratio is 4:9. So that means, can I say the original beam must have been 13K length, must have been of length 13K. Considering each broken piece as a separate beam, how much gain or loss with respect to the market value of the original beam before the accident is incurred? Let's try to observe this. Now here, can we say for the original beam whose length is 13K, what is going to be its value? So value of the, in the first case, the original beam, right, will be directly proportional to 13K whole square, isn't it? Can we write it simply as, so value of the first, the original beam, can we write as 13 square is 169 into something A, because some constant will also come in here. To remove this proportionality sign, we put in A as that constant. So value of the beam, unbroken beam, was 169A suppose. Now what can we say about the value of this particular smaller beam? So its value, suppose V2, will be directly proportional to 4K square. So this further means V2 will be equal to 4K square is 16 into same constant, because we are dealing in the same situation. So here the constant is A, we will also take the same constant here as well. What about the second broken piece? Let's call its value as V3, is directly proportional to 9K square. So this would mean V3 will be equal to 9 square, 81, same constant A. So the original beam was 169 units, 169A. The two smaller are 16 and 81A respectively, 16A and 81A respectively. So what's the combined value of the broken beams? So if you look at the combined value, V2 plus V3, it's 16 and 81, 97A. So as we clearly see, the value is reducing. After the accident, the original value was 169 parts, now it is only 97 parts, so it is reduced definitely. How much has it reduced? He is asking us by what percentage. Considering each broken piece as a separate beam, how much gain or loss with respect to the market value, this is the market value of the original beam, before the accident is incurred. So can we write it here? Can we write it here? The loss incurred will be how much? 169 minus 97, which is what? 72A. And hence the loss percentage will be nothing but the loss value upon with respect to the original beam value, 169 into 100. Okay. So here let's try to simplify this. How much would we get here? So if you take half of this, so half of this is around 84.5. So my answer is less than 50% loss. So less than 50% loss, we definitely is not the answer. No gain or loss is also wrong, because there is certainly some gain or loss. So either A or C, and of course D is also wrong because it's talking about gain. So either A or C is the answer. Now for checking A or C, we can do one more step of calculation. Now 169A, what is 10% of it? 16.9A, right? So what will be 40% of it multiplied by 4? So right hand side will also be multiplied by 4. 16.9 into 4 will give you what? 67.6A. So can I say, had in the numerator we had, in case we had 67.6A, my answer would have been 40%. Right now it is more than 67.6A. Can I say my answer will be slightly more than 40%? And hence C is also incorrect. My answer finally I can mark it as option choice A. So this is how we could answer. Alright. So we're done with the first question. Now let's move on to the next one. Question number 2. ABCD is a rectangle where the coordinates of C and D are consecutive vertices, are minus 2, 0 and 2, 0. By the way, please note that these 2 points lie on x-axis. So thus if you look at the rectangle, if I take the x-axis and y-axis, the rectangle will be like one vertex is minus 2, 0, C it is. The other vertex is 2, 0, it is D. So this is how the rectangle is lying. So basically one of the sides is on x-axis, that means the other sides, perpendicular sides, will be along the y-axis, correct? And the final side will be parallel to the original side. So my rectangle will look like this. So suppose this is A, this is B, right, C and D. So this is how the white would be the rectangle. If the area of the rectangle is 24, so we know that area of a rectangle is length into breadth. So right now here, what is length of this side? So minus 2 to plus 2, it is 4. Suppose the other side AD is some x. So can I say 4 into x, area of the rectangle is given to be as 24. That means x will be equal to 6. So if x is 6, can I say the coordinates of point A will be the same x coordinate 2 and 2, and y coordinate will increase by 6, 2, 6, and similarly same x coordinate, 6. So A and D vertices are also known after this input. Which of the following is a possible equation representing the line AB? See, why is he saying possible equation? Let's try to understand that. Because we have drawn the rectangle like this, there could be one more possibility here. Think about this also. So this is your x-axis, y-axis, the rectangle is like this. Now instead of going up above the x-axis, we could also go below the x-axis. So the rectangle could also be like this, C, D, A and B. So that is why he is saying possible equation, right? I hope this point is clear. Now let's continue. Which of the following is a possible equation representing AB? Now if you look at in this case, what is equation of AB? So as we see above easily, equation of line AB will be nothing but it's parallel to x-axis. Equation of x-axis is y equal to 0. Any line parallel to x-axis will be y equal to k, and here as we see the y coordinate is 6. So it will be y equal to 6. Had I taken the rectangle below the x-axis, then it will be y equal to minus 6. Okay. So but in the given options, we see option choice B is given to us. Hence, that should be the correct answer. So we could solve this question in the following manner. I hope we are clear with this. Let's move on to the next question. Question number 3. It says Adu and Amu. Third question. Adu and Amu have bought 2 pieces of land on the moon from an e-store. Both the pieces of land have the same perimeters, but Adu's piece of land is in the shape of a square. So for Adu, the land is as follows. it's in the shape of a square. Let's suppose the side of the square is A units, and Amu's piece of land is in the shape of a circle. Suppose the radius is R. Now it says both the pieces of land have the same perimeter. So perimeter of the square should be equal to perimeter of the circle is what is given to us, and we know perimeter of a square is 4 times its side, and that of a circle is 2 pi r. Both are equal. So if both are equal, that would mean A by R can we write as pi by 2. Okay, so the ratio of A and R is pi is to 2. Now what is he asking us? He is asking us ratio of the areas of Adu's piece, so square, and that of Amu's piece of land. So can I say the required ratio is nothing but, area of Adu's piece of land will be A square is to, so that means by, area of Amu's piece of land will be pi r square. Now we already know A by R is pi by 2, substitute that. So A square by R square will be pi square by 4, and there is one more pi here. So pi and pi will cancel out, and finally we will be left with the ratio of pi is to 4. So the ratio would be pi is to 4, option choice E will be the correct answer. Alright. Question number 4. Ramesh bought a mobile from a local store. He paid 1/6 of the price via UPI, 1/3 of the price via cash. So let's stop here. So 1/6 and 1/3, look at the denominators 3 and 6, take the LCM 6. So let's assume the price of the mobile, let the price of the mobile be LCM of 3 and 6 is 6. So let's say 6x. So out of 6x, how is he paying? How much is he paying by UPI? So UPI he is paying 1/6 of it. That means x rupees. How much is he paying via cash? Cash is 1/3 of it. So 2x. So overall he has paid 3x out of 6x. Please note. So what is the balance amount? The remaining amount will be 3x. Now what is he saying about this remaining amount? Let's look at it. He agreed to pay the balance amount a year later. So this 3x will be paid next year, a year later. While paying back the balance amount, Ramesh paid 10% on the balance amount. So that means on this 3x, the interest to be paid will be 10%. If the interest paid was 6,000, so this is given to be as 6,000. We can definitely find out the value of x here. So when you solve this, 10% means 1 by 10 goes on the other side, will become 6,000 into 10 is 60,000. When you solve this, x will become 60,000 by 3, which is 20,000. What is he asking us? What was the original price of the mobile? So thus can I say my answer, the original price will be 6x. So 6 into 20,000, which is 1,20,000. So option choice D is going to be the correct answer. Alright. We could have also taken it as x and solved it. Not very different, but this will be slightly more convenient. Taking 6x is better. Question number 5. There are 25 rooms in a hotel. Each room can accommodate at the most 3 people. For each room, the single occupancy charge, so that means if one person is occupying the room, the charge is 2,000 rupees per day. Double occupancy charge is 3,000 per day, and triple occupancy is 500 rupees per day. So at this moment, let's try to do one calculation. So when you go for single occupancy, what is the per person charge? So if you go for single occupancy, the entire amount is to be paid by one person only, so 2,000 rupees. If you go for double, so the amount will be shared between 2 people, so 3,000 by 2, it will be 1,500 per person. And if you go for triple occupancy, then it will be 3500 by 3 per person. This is going to be what? 1166.66. So that means if you notice, the least amount would be when you go for least amount per person would be when you go for triple occupancy, later for double occupancy, finally the highest cost per person comes for single occupancy, as we see from this table. Anyways, let's read it further. If there are 55 people staying in the hotel today, what is the maximum possible revenue from room occupancy today? Room occupancy charges today. So there are 55 people and there are 25 rooms, right? 25 rooms was given to us and there are 55 people. So one thing firstly here, please note, if you try to accommodate single persons, then you would be getting maximum revenue per person. But for accommodating 55 persons, you need 55 rooms. We do not have that. So let's try to do one thing. Let's try to maximize the number of single occupancies that we can have here, single occupancy rooms that we can have here. Let's try to send 25 people out of this 55 to those 25 rooms. So room 1, room 2, room 3, room 25. So I'm sending one person each. So 25 persons are gone. Now there are 30 more people remaining, 30 people remaining. So what I'll try to do is, I want to maximize single room occupancy, right? Maximize single room occupancy. So what I'll try to do now is, please notice, from room 1 to room 10, how many are remaining? By the way, please notice, room 1 to room 25, one person was gone in each room. So out of 55, 25 are gone, accommodated, 30 are remaining. So what I'll do is, from room 1 to room 15, somewhere here, I'll send 2 people more. Because see, again the objective is I'm trying to maximize single room occupancies. But even if I try to do that, here I'll get 2 more people, 2 more people, 2 more people, 2 more people. And here all it will be 1, right? Room 16 onwards it will be 1. So that means in this case, please note, there are 15 rooms, single occupancy, and there are 10 rooms, triple occupancy. Triple occupancy. So 15 room single occupancy will give you how much revenue? The revenue will be 15 into 2000, just 30,000. 10 rooms triple occupancy will give you what? Triple occupancy cost was 3,500 rupees per day. So 10 into 35 will give you 35,000. So this way we see that we can get 65,000. But clearly it's not matching with any of the option choices. So hence we could conclude that this kind of thinking was wrong. So trying to maximize single occupancy room did not yield the required result. So let's try to think of something else. So we have room 1, room 2, room 3, room 25. Now we have 50 people. Let's try to, because see the difference between these two is only 500. The gap is only 500. That means if I'm trying to convert a single occupancy room to double occupancy room, the cost, the revenue will come down by 500 rupees per room, right? 500 rupees per room. Now please note, here what I'll try to do is, instead of focusing on single occupancy, let me try to put as many as possible double occupancy rooms. So in each room, I'll send 2 people, double occupancy. But this way I'm only able to accommodate 50 people. There are 5 more people remaining. I will send those 5 people to the first 5 rooms. So that means in this case, you have 5 rooms with triple occupancy and you have 20 rooms with double occupancy. So what's going to be the cost? Let's look at it. In this case, not the cost, the revenue, the charges will be, one triple occupancy was 3,500. So 3,500 into 5 will be 17,500 less. Double occupancy was 3,000, I think. Yeah. 3,000 into 20 rooms, 60,000 rupees. So which is going to give us what? 77,500 rupees. So this is clearly better than this. So focusing on single occupancy rooms was not a good idea. Anyways, here single occupancy rooms we got only 15. There we are getting double occupancy rooms more. There are 20 double occupancy rooms that we are getting. Okay, so that will definitely give us, right, a better overall revenue, right, a higher value. So this is going to be our answer, 77,500. Let's look at the options. Yeah. So once again, you can just have a look at this working. I'll clean it. So 77,500. This fourth option choice should be the answer. Sixth one. Arun selected an integer x between 2 and 40, both inclusive. So that means Arun is selecting from this list. He noticed that the greatest common divisor of the selected integer x and any other integer between 2 and 40 is 1. So if the greatest common divisor is 1, that would mean what? I want this x, whatever x we are selecting, to be co-prime with every other number, We want it to be co-prime. How many different choices for such an x are possible? So one thing is, if you want HCF to be 1, the GCD or HCF to be 1, you should focus on prime numbers, because prime numbers tend to have limited factors, only 2 factors and no common factors generally, right? So let's say to focus on the prime numbers here. So if you focus on the prime numbers, so 2, 3, I'll just write down 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31 and 37 only. I will not focus on the rest. For example, I cannot take 38 because 38 will definitely be having some common factor with 24, both are even. 39 will definitely have some common factor with maybe 6. 40 will have some common factor with 24. Right? So that way we will only pick the prime numbers. So how many prime numbers do we see here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So most likely many students would be marking 12 as the answer. But please notice, what is the condition? So this is a very trick question. Right? The greatest common divisor of the selected integer and any other integer between 2 and 40 is 1. For example, if you select 2, 2 and 4 will have some common factor. So hence 2 cannot be selected. GCD is not going to be 1 for 2 and 4. 3 and 6, there is some GCD, so it's not selected. 5 and 10. See, 10, I am just taking one example, it could be 5 and 15 also, 5 and 25 also. Right? 7 and 14, GCD is not 1. 11 and 22, 22 is also there in the list, in this list. 13 and 26, 17 and 34, 19 and 38 is also gone. But 23, there is only one single multiple, 23. 23 into 2 will be beyond this range. So thus 23 and any other number, HCF is or GCD is going to be 1. Same with 29 and any other number, GCD is going to be 1. Same for 31 and 37. So only these 4 are to be selected. So my answer is not 12 as people will generally mark in a hurry. The answer is actually E. Do let us know, like how many of you have made this mistake, right? How many of you marked B as the answer, because in a hurry, in state of that time crunch, right, where there is a time pressure also, we tend to make such errors. Very common mistake. Seventh one. If A, B and C are all positive integers with 4A greater than B, then which of the following conditions is both necessary and sufficient for the expression, this given expression, to be a positive integer? Now let's try to focus on that expression once. So you have 3 power A, 21 is nothing but 3 into 7 whole to the power 3A minus B. 49 is nothing but 7 square whole power 2B plus. Now let's simplify. So 3 power A, this is 3 power 3A minus B. into 7 to the power 3a minus b into 7 to the power 2 into 2, 4b plus 2c. Let's simplify more. So 3 to the power 4a minus b. When the bases are same and the numbers are multiplied, the powers get added. A power m into a power n is a power m plus n. Same way here, we'll get 7 to the power 3a minus b plus 4b plus 3b plus 2c. So that means this expression that we have here, which is given in this form, when simplified will become this much. Now there is also a cubed root attached to it. So let's also add that. So when you add the cubed root, this can be written as whole power 1 by 3. That means it will be by 3 here in the power, by 3 here in the power. Now we want this expression to be an integer. Now when is it going to be an integer? Think about this. So of course you want your power to be some integer. So 3 to the power 0.1, for example, is not going to be an integer. However, 3 power 1 or 3 power 2, 3 power 7 is going to be an integer. So can I say here I want these expressions 4a minus b by 3 and 3a plus 3b plus 2c by 3 to be an integer. They must be an integer if you want this entire expression to be an integer. Now think about it, when is 4a minus b an integer? So 4a minus b is an integer when 4a minus 3b is divisible by 3 or 3 divides 4a minus b. Now this 4a minus b, can we write it as 3a plus a minus b by 3 by 3. This anyway is divisible by 3, ignore that. Now if you want 4a minus b to be divisible by 3, in turn we mean to say a minus b must be divisible by 3. I write it like this, but don't read it as we generally do. I am reading it as a minus b is divisible by 3, I mean to say here. So that's one condition that must happen, alright, it's a necessary condition. And similarly, when will this part be an integer? So 3a plus 3b plus 2c by 3, this anyway is divisible by 3, anyway is divisible by 3, so ignore it. So 2c by 3 must be divisible by 3 and 2 is not divisible by 3. Hence can I say c must be divisible by 3. This is second condition. So that means if you want this and this to be an integer, can I say a minus b must be divisible by 3 and c must be divisible by 3. Now this is going to be our necessary, alright, and sufficient condition, right. If a minus b is divisible by 3, then we may say this definitely is an integer. If c is divisible by 3, then also we can say this is going to be an integer. So a minus b is divisible by 3 and c is divisible by 3. So option choice A is going to be our correct answer, necessary and sufficient. So sufficient because if a minus b is divisible by 3, this is definitely an integer, and c is divisible by 3, this is definitely an integer, irrespective of the values of a and b. Whether a and b themselves are divisible by 3 or not, we don't know, but a minus b is divisible by 3 and c is divisible by 3, then yes, I'll get an integer for sure. So it's sufficient. Alright. And C, if you look at the other options, a minus b equal to c or a, b and c are divisible by 3. So this might also be sufficient, right, but not necessary. So it's not going to be necessary here, right. We cannot say anything about a and b, but a minus b we can definitely say this, right. So a minus b and c are divisible by 3 is both necessary and sufficient condition for the given expression to be a positive integer. Next one, question number 8. For how many distinct real values of x does the equation below hold true? Consider a to be greater than 0. Anyways, if a is written in the base, it is assumed to be greater than 0. So if you look at this equation given to us, x square into log 16 to base a by log 32 to base a. So we have one property in logarithm, right? Log m to base x by log n to base x is nothing but log m to base n. By using that, can write the first term of the equation as x square into log 16 to base 32 minus, let's write that x, minus log 64 to base 32 equal to 0. So we have got rid of that a. Now, in this case, observe what is this value 16 to base 32 log 16 to base 32 is 2 power 4 and this 2 power 5. So, 2 power 4 will come before the logarithm, 2 power 5 will come before the logarithm in the denominator, log 2 to base 2. 2 power 6 and 2 power 5. So, 6 will come in the numerator and 5 will come in denominator, log 2 to base 2. This is 1, this is also 1. Now, let us simplify. You can take the LCM of 5 in denominator and simplify, you will get what? 4x square minus 5x minus 6 equal to 0. It is a quadratic equation. So, this is reduced to a quadratic equation, and we know quadratic equation can have no root, no real root, one real root or two real roots. That will all depend on the discriminant here. So, what is the discriminant value here? B square minus 4ac. So, discriminant will be nothing but minus 5 whole square, 25, minus 4ac, 4 into minus 6. See, this definitely minus into minus will make it plus, this is definitely greater than 0. So, if it is greater than 0, it must have, discriminant is greater than 0, that means the given quadratic equation must have two roots. It must have two roots. So, option choice B could be the answer, but one more thing, there is one more option given to us, depends on the value of A. See, here there is some ambiguity. I would like to give you both the aspects. When he is writing A in the base in the given equation, A is written in the base, and we know that in a logarithm the base can never be 1. So, it is understood that the base A that we are writing when he says is greater than 0, of course it should be positive, but it should not be 1 also. It should not be 1 also. So, thus if I consider that A cannot be 1, then my answer is 2. However, if I still write A as 1 in this equation, that means the base is becoming 1, and if base becomes 1, the logarithm is not really defined. We do not consider the logarithm. If we do not consider the logarithm, that means there is no such equation which is formed. The equation is not valid, and if the equation is not valid, then we will have 0, no roots, no values of x. So, then we may mark A as the answer, right. So, depends on the value of A, because if A is 1, but still I am repeating that since A is written in the base, we do not take it as 1. So, A equal to 1 is rejected, and hence we will mark B as the answer.